Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our deprogramming language series. In this lesson, we're going to be looking at destructors and structs. Now, if you're coming from a background like C++, you're going to find that structs, destructors work relatively the same way. And they follow principles like RAII, which is resource acquisition is initialization. But let's just go ahead and look at some examples, starting with a language reference, and then we'll get into some code. So let's go ahead on dlang.org to click on documentation, language reference, down to structs and unions. And then I'm going to go ahead and just move this over here. And let's go ahead down to select struct destructors here and observe what a destructor is. Now, again, for those of you coming from languages like C++, this is going to be familiar, but basically this is a special member function. And you can see that it has the tilde mark and this in front of it. And remember that we use this for constructors, as can also be seen on the left side here. And the destructor just has the tilde marker in front of this. And you only have one destructor in the deprogramming language for structs, and that's all you need. And its job is to free up resources that are owned by the struct object whenever it goes out of scope or its lifetime ends. So I think it's easiest just to see an example of this. We can see a few of the other cases with the deprogramming language for how structs act. And basically they will, if I have some other object within a struct, it will also call those destructors within the destructor here. All right, and as mentioned, this concept of RAII applies, and you can explicitly call a destructor early if you want using destroy from the standard library, but let's just go ahead and work with some of the basic examples here. So this example that I've set up here, I've just created some type here with the name A here. I've got our constructor. I'm just going to write out that this constructor was called for this type and maybe do something with its field. And then let's go ahead and call or create a destructor, again with that special tilde mark. And this here, no arguments provided, and then our little printout to let us know that the destructor was called. Now, again, if I go ahead and run this example here, let's just go ahead and run it. You'll observe that the destructor is being called, but we want to call this constructor. So we do need to provide, for instance, the actual constructor that we want to use, passing in one integer method. And if that's not familiar with you, make sure you go back to the previous lessons where we've talked about constructors before we move forward on this lesson. But anyways, if you're comfortable with that, we can clearly see that in this main function, when we hit this A type here, we call our constructor, that's over here. And then when we leave the scope here, which would be leaving our main function, this function is automatically called. So you can see just by declaring this type here, we are effectively constructing it, which a constructor we can think of as a sort of special member function call, but really it's just us constructing this type in memory and initializing its fields. But the destructor is an actual function that's called when we leave scope here. Okay. And again, this occurs when we leave the lifetime here. So for example, let's just go ahead and do a few little printouts here. If I go ahead and write, the start and the end of our program, go ahead and pause this and convince yourself, well, when is this object called type here of the data type A here, when is this actually going to get called or created for the constructor? So when is this going to print out? And then when is the destructor going to be called? And you can pause the video here and just see if you can make a correct guess. And if you did pause the video here, and I'm going to go ahead and run it, let's go ahead and look at this program. So I write out start, then I call my constructor here, then I get to end, and then this destructor is automatically called, which will execute some code here at the very end of our scope here, or our lifetime. Okay, so that's when it's called here. And again, you can do this example by creating different scopes here, by putting in the curly brace here. Okay, so I'm going to make one more change here, and I'll leave that available on the program, so that you can see now I've changed the order here, where you can see that, well, this is the scope of my actual object here. Okay, this is where it leaves scope, so the destructor is called automatically as soon as we hit the end of its lifetime here. Okay, and then we get the end message here. So that's something really important to keep in mind with our destructors and when they're called, that they automatically leave scope. So let's go ahead and just take a look at this example again. But what I'm going to do here is just create a copy of this struct here. And I'm just going to name it B for lack of a better term here, just so we have some other object here with a different printout. And what I'm going to go ahead and do here, again, to show you the order if I have multiple structs here. So let's just go ahead and create B. I'll just call it type 2 here. And this is of type B. And the values don't really matter here. But what you want to look at here is, and this is a common interview question in interviews for languages like C++, is think about, well, the order that these objects are constructed. If A is constructed here, this first type, before type 2, what order should they be destructed in? Okay, so let's go ahead and take a minute to pause the video, and I'll let you think about this. And if you took a moment to think about this, let's go ahead and see what the result's going to be. I'm going to go ahead and run this, and we're going to see that A is constructed, as we see in line 37 here, or this type here of A, the variable's name is type. And then something of type B is constructed here. And then B is destroyed first, and then A is destroyed. So we do have this deterministic order. And if this is new for you, let's just go ahead and think about this in terms of the code here. So recall that structs are going to be allocated on a stack here. So I'm going to go ahead and put in a stack here. And this is my stack, which we can think about entering objects in here. The thing that is of type A here, so I'll just label A here, and then the thing that is of type B. So then the order that they're going to be destroyed is, well, I've got to grab the first thing here, and I destroy B, so that's why I call B's destructor, so for B here, and then I'll destroy A. Okay, so that's why we get the printout order here, where B's destructor is called first, and then A's. So it's sort of in the reverse order, if you want to remember it that way, in which objects were constructed. If I construct A first, that'll be the very last thing that's automatically has its destructor called if it's in the same scope, which both of these fall in the same block. So again, we can play around with this just a little bit if we want, and I could go ahead and move A out to another scope. But I'm effectively extending its lifetime, right? Because A's scope is within the main here. So let's go ahead and try this example. And here you'll see that A is created, then B is created, which is shown here. And then B reaches or leaves its scope here at line 39. So the destructor is called. And then finally, A's destructor will be called when we reach the very end of our program here at line 41. Okay, so you can kind of play around with these examples in little silly ways just so you understand that the order of the destruction is deterministic. Now, again, why do we want destructors on this principle of what is known as, and I've mentioned it once, but I should write it out here for you, RAII, okay? Which was a name sort of coined in C++, which is Resource Acquisition is Initialization. And even Bjarne Stroustrup, who coined this term, said it's a little bit of a silly name, but it's kind of stuck. In a way, it makes sense. But what this means is, and let's go ahead and just sketch out another struct for this here. Let's just create a new one here that might be a little bit more useful. And let's just go ahead and call this just some general resource. So for example, let's go ahead and say if I have some file here, and then in my constructor, I want to load or set up this file here. I don't know, myfile.txt, something like that. Okay, so let's make sure that this much works here. Oops, and I need to pass in, well, let's actually pass in a file name. So I might do something like this here. Okay, something like this, just to load up a file. But oftentimes what we want to do here in programming languages is make sure that we also close that file. So in a way, we could create this wrapper here to ensure that we always call fclose, for instance. Okay, so that can be a way to enable resource acquisition is initialization. Now, for files itself, they are a struct, so we actually don't need to call close explicitly because that's, again, just part of the safety here. So again, oftentimes these types here, as mentioned, if this does itself have a destructor, and I'll just go ahead and put in notes here, f's destructor will be called here as well, because it's a field in a resource, a field or a member function. So again, we don't have to worry about, for this one, it will actually close its resource. But if we have other things, and again, this is jumping a little bit ahead if you're just beginning programming, but if you've been programming and are just looking at D, but if you have things like, for example, a mutex that you've opened, some file stream, some network connection, you, again, if you don't have, or if you're wrapping, say, a C library, you'll want to initialize your resources in the constructor and then make sure to free them in the destructor. And again, it's an easy way. Again, sometimes folks might provide functions like a destroy that you can explicitly call, but this is an easy way to remove the burden on the user and make sure that your resources get destroyed within the scope. And in other cases, again, this is getting a little bit advanced where you have things like exceptions that could occur in your program. We ensure that the destructor is called as well. All right, folks, so I hope you enjoyed this lesson here. I'm going to go ahead and leave it off there. And if you'd like to follow along and track your progress, of course, make sure that you're following along all these lessons with structs here. You can find my various courses here, and specifically the D language course here if you'd like. And as always, I'll look forward to your discussion and comments in the below. And I've really been appreciating the support from those folks who are members of the channel, everyone who subscribed, and these great discussions we've been having in the comments. So with that said, I'll look forward to talking to you folks in the next one. And we're going to go ahead and destruct this video in 3, 2, 1.